With in today's video, I'll be solving some Cengage example questions that have helped me boost my concept, and I have to revise these before JEE mains. All right. So first is from differentiation chapter. We have f of x plus y is equal to 2 f of y plus y root over fx, and f dash 0 is equal to 0. Then you have to find f of 6 is equal to what, and it's a continuous function and stuff. So the approach is you write f dash x is equal to f of x plus h minus f of x divided by h. Now you plug in the values, right? You plug in this function back over here, like you plug in what, this function back over there. So your value will become f dash x. So yeah, here's there's some crazy manipulations that you might have to do. You might have to write fx as fx plus 0. And then if you expand it, if you notice that if you put x and y as 0, you'll get f of 0 is equal to 0 from this functional equation. So if you write this as f of x plus 0, this will just become minus 2fx, and this will get cancelled. All right, so now we just have a h over here. Now f dash, it's given that f dash 0 is equal to 0. So f dash x is equal to x into fh minus f0 divided by h, right? Plus root over fx. Then from here, we can say that this is also 0 because of f dash h equals 0. So from here, we can conclude that f dash x by root over fx is equal to 1. Now, if we integrate both sides, we'll just get fx is equal to x square by 4. Therefore, f of 6 is equal to 9. So these kind of questions are very popular, but we'll be still revising them. As you guys can see that gx is equal to f inverse x. So you can write y is equal to fx, f inverse y is equal to x, and we're assuming that gx is f inverse x, right? So we have to find g dash. So f inverse dash y into dy by dx is equal to 1. So f inverse dash y is equal to 1 by f dash x. Now, in this function, we basically need to find f dash x, but at what point? They're asking minus 7 by 6. So let's put some common points over here. As expected, you can see that you have a e power term. So you have to put x is equal to 1 because feel. So if you put x is equal to 1, you'll get minus 7 by 6. So we need to find f dash 1. So f dash 1 you can easily calculate, correct? So to find f dash 1, so f inverse dash value is equal to 1 by 5 because f of 1 we had gotten as 5 by differentiating and putting. So next question is this one. Fx is equal to f dash x into f double dash x. They had given that it's a polynomial. Okay, fx is polynomial and its real coefficient and leading coefficient alpha, we have to find 1 by alpha. So if you multiply both sides by f double dash x, I mean f dash x, and then integrate it, either we can think to solve this and get the leading coefficient, and you will get a 3-degree polynomial, which you can also say that, like, you can also say that it's a 3-degree polynomial because fx is equal to f dash x plus f double dash into f double dash x, correct? So every time you differentiate, the degree of the polynomial will come decrease by 1. So n is equal to n minus 1 times n minus 2. I mean plus n minus 2, right? So from here, we can get the value of n. So n is equal to 3, right? It's a 3-degree polynomial. And from here, you can get the equation. Assume a polynomial to solve it, like ax cube plus bx square, like that, and then put the value back in. Your answer will be 18. C and D, we have two basics questions. Question is, fx is given as this, and they're asking discontinuity point in the interval of -2 to 2. Basic property states that the function, if this is discontinuous and this is discontinuous, you have to check if it is continuous, it's continuous. If it's discontinuous and continuous, it's discontinuous. All right. So this both are discontinuous at x is equal to 0. So we'll check positive x. This will open as x, and x coming from positive, this will open as 0. So it is 0 value exact. Then if you check negative, this will give minus x. If you check negative from here, box of something tending to negative of 0, which means from the left side, right? So this will become -1. So it will become 1. So then upon putting the limit, we get 1. So at 0, it's discontinuous, right? And then box x, we can check the because now we have a doubtful point done. So now box x is just discontinuous at 1, 2, -1, and -2 we have to check because -2, it's coming from negative of 2, correct? Meaning coming from positive of 2, right? So like we have to check for checking endpoint discontinuity, we have to come from the positive side of 2. So it's slightly greater than 2. X is slightly greater than 2, right? So from here this will open as -x because obviously it's negative, and then we check directly on f of 2 and that. So this will be -2, um basically mod of x, so minus of -2, so it'll become 2 basically, and this is little bit less than 2, so it'll become 4. So this is 6, but it's not satisfied by f of -2 from the left side. So at 1, 2, -1 and 0, it's discontinuous. Then one more unique CND question. Actually, it's not that unique. Fx is equal to gx times mod of x minus 1 into x minus 2 into x minus 3 square into x minus 4 whole cube. And they have said that gx is a 3-degree polynomial, x cube plus bx square plus cx plus d, and they have given f dash 3 plus f triple dash 4 is equal to 0, and they've asked g of 5. So this is basic idea. um Mod of something squared is always going to be continuous. So gx, so mod of x minus 1, mod of x minus 2, mod of x minus 4. So as you guys can clearly see that for the function to be differentiable, जो fx है, it clearly have to have the roots 1, 2 and 4, right? This condition is kind of useless because I'll explain, right? F dash 3, if you differentiate it, every term except one term should have a 3 term, so that will become 0. That means g of x root has a root at 3. Same you could say for 4. So g of x has a root at 4. We could say f triple dash x is also having a root at 4. That means gx also should have a root at 4. Therefore gx we can write as x minus 1, x minus 3, 2, and x minus 4. Now putting the value 5, they have asked g of 5. So 4 into 3 is equal to 12. That's your answer. So as an important property I want to highlight is that gif of x plus gif of x plus 1 by 3 plus gif of x plus 2 by 3 is equal to gif of 3x. This is true for any n numbers, right? Because you can just keep going and they'll be equal to gif of nx. It is given by Gaurav sir in his class. So fx is given to us as what do you say, x by 1 plus ln x in multiplication infinity times, and x belongs to 1 to 3. This function is non-differentiable at k, and we have to find mod of k square. I mean box, meaning GIF of k square. All right. So obviously we have two cases here. When ln x, meaning ln e, right? This is ln x. If x is less than e but greater than 0, sorry, greater than 1, then function opens as x. But at greater than e, function opens as 0. So obviously we can see that the function is discontinuous at e, therefore e square box is equal to 7. There's another case you can take actually for your g, like the function itself. You can take ln x is equal to 1. That case also works, so you'll get x by 2 actually. Last question on functional equations. Given that f of x plus y is equal to this equation, and it's also given that limit h tends to 0. So first, like, I mean, sorry, they've given limit h tends to 0 of this quantity, and they've asked for box of f of 2. Sorry, GIF. No one calls it box, sorry. So the limit that's given is f of h minus 1 by 3 divided by 2h, putting this function. Alright, you can write this as 0 plus h. And you can put this function actually over here, or h plus 0, anything. Otherwise, what you can do is you can use first principle directly. We want to find f dash x, because then we can integrate both sides and get something. So f dash x is equal to f of x plus h minus f of h, sorry, f of x divided by h. From here quickly you can get that f of 0 is equal to minus 1 by 3. Sorry, a little mistake I did. F of 0 is equal to 2 f of 0 minus 1 by 3. So 1 by 3 is equal to f of 0. So using this popular manipulation, I'll try to expand it and let you guys know. Sorry, I've written the question a bit incorrect. It's f of this thing, right? It's this thing. Don't get mixed up. So we have these terms left now. Limit h tending to 0, obviously. From here, this is evident that this is f dash 0 and this is 2x square after putting the limit. And then we can calculate f dash 0, right? Because they've given this part. This part is to calculate f dash 0 itself. So f of h minus 1 by 3 divided by 2h is equal to 2 by 3 limit. So if we take this 2 over here, because it's not affecting the limit, right? H tends to 0. Notice that this is nothing but f of 0. So minus f of 0. Is it f of 0? F of 0 is 1 by 3, correct. So from here f dash 0 is equal to 4 by 3. So from here we can get 4 by 3 plus 2x square is equal to f dash x. Now integrate both sides and get the answer. This come in JEE Mains before and it can come this year is what I'm predicting. Then in AOD we have a gem question which can be asked by JEE Mains. Fx equals e power x and gx is equal to log base ex, or ln x actually, it looks better. Then the value of d power 6, where d is the minimum distance. So given that this is the graph, we can say that the tangents at these points, right, they have to be parallel to y equals x. So now we just have to find the tangent and find the point where the tangent is equal to 1. So from here we can notice that y, meaning we have to find dy by dx at x1, right? And we have to equate that to 1. So obviously x1 is equal to 1. And here x2 जो है, it is equal to 0. So we can say that the point is 0 comma 1 and 1 comma 0. So now the distance between these 2 points is root 2 and they've asked for d power 6. So 2 power 3. So 8 is our answer. Before J Advanced, I'll be covering more questions based on AOD because they're based on tangents actually. One question based on geometry also should happen because they, I mean, they can ask, right? From given cone height is capital H, an inverted cone, sorry, is carved of height small h. So this given cone, this height is given as h. Okay, and we have to basically find what is that ratio h by h so that this cone's volume is maximum. So we can say that these two triangles, okay, these two triangles and this entire triangle is similar, right? So from here we can conclude that using the similarity, r by capital R is equal to h minus h by h. Oh yeah, and r is equal to h minus h divided by h into capital R. Also, I'm pausing the video a lot because I'm also trying to solve it parallelly because that's how it is, right? So then now we can write volume is equal to 1 by 3 pi into small r cube, right? Then we can use the given relation v is equal to 1 by 3 into pi into h minus h by h, right? Whole cube into r cube. Then we have to maximize for small h. So we'll write this as h minus h whole cube divided by small h cube. Otherwise, we can do one thing and take the h inside and write it something like this. I think that will be a little weird to differentiate, but it's okay. I mean, I don't think it matters at this point. Wait, let's see if it is right. Sorry, this is capital H, I think. Capital H, yeah, this should be capital H. Now it makes sense to differentiate. If this is capital H, then you just get 1 minus small h by capital H whole cube. Then you can take dv by dh very easily, right? You can take dv by dh very easily. Basically, you'll get 3 into, did I divide it properly? Yeah, I did. So you get 3 into 1 minus h by capital H whole squared times minus of h, no, minus of 1 by h into r cube is equal to 0. Anything am I doing? Am I missing something here? Oh shit, I wrote the. Oh my god, I'm stupid. This has to be into h, like that's a volume formula, right? So this will become h square into h. Okay, yeah, okay, my bad. So if you take this inside, it will become h cube and then h. Okay, so it just becomes different. So dv by dh is equal to pi capital R square by, you're replacing r with h minus h by h into r square. Yeah, so pi r square divided by 3 of h square into h minus h square into h. So then we just apply that rule, no, product rule or whatever. Yeah. So this is, let's just say this is all k into h minus h square plus what, differentiation of this, so h into h minus h squared is equal to 0 from here. Otherwise, instead of doing that, we can just keep this as h minus h times h is equal to 0. So h minus h times of your capital H, also k is multiplied with everything, right? So we can just eliminate k. So capital H minus h plus 2h is left, I think. Minus h minus 2h, correct. So from here we can notice that h is equal to h by 3. But approach is same. You just use similarity and you just differentiate it. Moving on to indefinite integration, we have a standard saval. Sine of 101x into sine 99x. This you can split it as sine of 100x plus x into sine of 99x Then just use sin A plus sin B formula. Then after that, it becomes pretty standard integration. Basically, you'll see the by parts used over here. Sin 100x cos x into sin 99x. Okay, integral plus integral sin x cos 100x sin 99x. So that's just what sin 100x into cos 100x, sine power 100x obviously. So from here you can just notice that if you use by parts on this, you're bound to get something like this, right? I mean, it's kind of obvious here, so you will apply it. So it's called cancelling integral. Sine 100x cos x sine 99x plus integration of, actually no, we can just differentiate easily. What can we differentiate? This one, I mean integrate, you can integrate this easily. So you get sine of 100x divided by what, 100 minus integration of 100 sorry, 100 times sine 99x cos x sine 100x divided by 100, because you're differentiating this and integrating this, right? And this will cancel and this will also cancel. So this makes it a really fun question, because the trick is to split this 101 into 100 plus 1, like that. Then we have a standard starred question in your Cengage. I mean, everyone has starred this mostly. Cos of 5x plus cos 4x divided by 1 minus 2 cos 3x. Integration of this. The approach is using cos A plus cos B here and creating that kind of term down here. So this is cos of 4x, right? So using it, yeah, we'll get 2 cos 9x by 2 and the cos of x by 2. Now denominator is your challenge. You have to create cos of 9x by 2 somehow. So basically the idea here is to create, I told you right, is to create this. I'm still thinking, like, this is kind of weird. I think the only best bet that we got now is to convert this directly to half angle. So using a half angle formula, cos 3x is equal to 2 cos square of 3x by 2 minus 1. Using this thing, we'll get this result. We'll get 4 cos square 3x by 2 plus 2. So that's 3. Okay, yeah, you see it now, right? This should be pretty spottable right now. So that's a beautiful question created by Cengage, because this kind of approach does not actually strike in the exam, right? So if you multiply this and divide by the infamous cos 3x by 2, we get 3 cos 3x by 2 minus 4 cos cube 3x by 2, which then proceeds to give us 2 cos 9x by 2 cos x by 2 into cos 3x by 2 divided by I think this is minus cos 9x by 2. Sadly, doesn't matter, it'll anyway cancel. And then I think the next part you can split this, because the denominator is fucked now. So 2 cos of x by 2 times cos of 3x by 2. If you can split this, you can write this as minus cos 2x, because there's minus from here, plus I think cos x, right? And that'll give us what? Minus sine 2x by 2. And this integration is what? Minus sine x. So yeah, that's the answer. Then I have some ideations to share. Like, if we take this problem, uh, 3 plus 2 cos x by 2 plus 3 cos x square. Now, if you see such patterns, right, what do? Like, you can't expand, you can't do shit, everything's the same angle. Just the coefficients are switched up. When the coefficient is switched up, multiply and divide by suitable reagent. Like here, if you multiply and divide by cosec square x, I'll give you a hint, right? Cos 3 cosec square x will be created. And 2 cot x cosec square x. Now do you see anything happening? See here. See here. Cosec x differentiation is what? Cot x differentiation is what? These two specific stuff, right? Doesn't that make it better? Like, it would make it so much easier right now. So if we multiply, we have to divide also. So that becomes 2 cosec x. Alright, cosec x. And since you're cosecing, sine will come right basically down. So it will come nicely, it will become 3 cot x. And then if you differentiate it, this term will come here, this term will come here. Alright, so it becomes very easy. And obviously got to take a negative sign outside. That's the motive for this question. We have to just multiply and divide by suitable reagent. And you see inverse of coefficients. Then we have problems like this: x f dash x minus 2 fx by square root of x power 4 into fx. Now problems like these will make you lose your mind. There's nothing you can do about it. But what you can do notice is that if you just think a bit, what does this look like? X square fx f dash x minus 2x fx. It would have been 5, right? So what do? We just create it. That's all. That's the solution, bro. That's all you do. And for that, now you need to multiply and divide by x power 4. And you can just see that f dash what? Sorry, x square fx. My bad, 1 second. Um, fx by x square is being created. Dash on the numerator, and denominator you can create fx by x square after you multiply and divide by x power 4. If you can see that in here, it will be very good. And then one more motive is there: e power x cube plus x square minus 1 into 3x power 4 plus 2x cube plus 2x. Okay, if this integrand is there, what do? We end up taking only this part of it, because x power 4 x cube, here x cube x square is present, so we take the part that's common. So that just becomes 3x power 4 plus 2x cube. And then what do we get? Integral of e power x cube plus x square minus 1 times what? 2x. And then dx over here, dx over here. Then again use by parts over here. By parts, why are we using? So that we can create this integral and then cancel it. Otherwise, you can, instead of directly applying, you can take x square common. E power x cube plus x square minus 1 into 3x square plus 2x. Now it looks kind of complicated, but I think after applying by parts, it should be coming. Just apply by parts with this and this, integrating, differentiating. I think you should be able to get this. Because if you see, if you integrate this, you'll get x cube plus x square. And if you differentiate this, you'll get the same thing. So आपस में they'll cancel. So area under the curve is just lengthy. I'm just skipping it by for now. For the last chapter, we have definite integration. First, we can look at, directly they might ask gamma function result. This one into e power minus x square dx is equal to 360. They can ask n is equal to what number. So just remember the result that comes out of this integral is n factorial by 2 is equal to 360. So directly n factorial is equal to 720. So n is equal to 6. That's a direct result. And then one question that has come before in like our tests and many other places, test series, lot of places, is that if fx, oh my god, 1 second. uh, yeah, so mm, so if fx is equal to, sorry, if f of x is equal to x, and we're asked to find f of 1 by 4 plus f of 3 by 4, we'll have to think in this direction. Okay, if this is given, sorry, my bad, we have to take composite function, you have to put x as fx. Okay, so f of x is equal to 1 minus f of x, and from here this is equal to 1 minus x. So f of 1 minus x plus f of x is equal to 1. So this kind of expressions are always equal to 1 whenever they have a lot of 1 minus x's in them. You should feel it and use King's rule when asked. Correct. Aside from that, we can take a look at a question that was asked in our notes, and it's also there in Cengage and many other good books. Is this specific problem 1 plus root 5 by 2, and this is 1 plus x minus 1 by x dx, and this is log of it. So already from here you can get that you have to get some sort of x minus 1 by x clue from here. So which is going to be creating that 1 plus 1 by x square into x square minus x. Okay, plus, okay, this becomes minus 1 plus 1 by x square, and this will become 1 plus 1 by x square into divided by 1 x minus 1 by x whole square plus 2 minus 1, right? So that will just become 1, and then we can just take this as t. So from here we get dt divided by t square plus 1 into ln of 1 plus t. Now the question is, what happens to the limits? Okay, so initially this will become 0, right? And this one, 1 plus root 5 divided by 2 minus 2 by 1 plus root 5. So if you take, what do you say, the inversion, root 5 minus 1 will come, right? Root over 5, no, sorry, 1 minus 5. I don't think, yeah, root 5 minus 1 is better. So if you multiply and divide by that, you'll get 4 over here and 2 down here, and 1 plus root 5 minus root 5 plus 1 divided by 2, and that all comes to 1. So it ends up being 0 to 1 itself. Now everybody knows that this integral is equal to pi by 8 ln 2, but if you want to see how it came, that's also very simple. Just put t is equal to tan theta, and then you'll get ln of what? 1 plus tan theta in integral 0 to pi by 4. Then just use King's and add. That's the approach. Now I'll be discussing a good mains level question, which is also lengthy. I'll be solving it completely. So if fx is a continuous function, integral 0 to x ft dt is equal to integral x to 1 t square ft dt plus x power 16 by 8 plus x power 6 by 3 plus a. Okay, then they're asking value of a. All right, so what you're going to do is you're just going to put the value. Fx is equal to, basically differentiate it. Fx is equal to minus minus x square fx plus 16 matlab 2x power 15 plus 2x power 5. One thing we have to notice is that from here, if you put x is equal to 0, we can directly get a's value, correct? What do we need? Integral of minus 2 minus, I mean 0 to 1, t square into t power 15 plus t power 5 divided by 1 plus t power 2, negative of this and twice. This value is equal to a, and in the options they've given only two negative values, and it does not look like one of them, so obviously we could have marked it very easily. But then integrating this should be very simple, right? We can just notice that it's a GP directly and write off x bar 13 minus x bar 11 plus x bar 9 minus x bar 7 plus x bar 5, like that, and integrate it. You'll get a pretty lengthy expression from here, and you'll finally get the answer as a equals minus 167 by 180, sorry, 840. Just the thought process you should have in the exam. It's not a hard question, but this calculation can mess up your entire flow. Also, an integral that directly came in J Mains 2026 is this one, 0 to pi by x into sine x cos x divided by cos power 4x plus sine power 4x is equal to I. This came directly in J Mains. What you had to do was very simple. And one more question that is going to be relevant for J Mains is integral minus pi to pi sigma r is equal to 0 to 999 cos rx into 1 plus integral of, I mean, sigma r is equal to 1 to 1999 sin rx dx. Now, um sine of minus x is sin x minus sin x, so we can just kings and add. So yeah, then we can just add them up, and then we get integral minus pi to pi. This 2 gets cancelled. So r is equal to 0 to 999 cos rx is equal to I. And I think a plus 1 should come somewhere. Mm. Anyways, it doesn't matter because we can just integrate inside this sigma. Take r is equal to 0, 999, integral minus pi to pi cos rx. In terms of r, you can find it. The integral doesn't even matter. Otherwise, you can integrate each r term and then you can just get the answer. Because anyway, this will all be sine terms, right? After integrate, it'll all be cos terms itself. An integral of an even function from minus pi to pi. I mean, you'd know what I mean, right? It's going to be 0, this part. It's going to be 0. And then one more type of question they've been asked in JMains 2026, sorry, 2025 is this one. Minus 2 to 1 box of x, double box, basically double box. So if you see behavior of cos pi x by 2 function, it's going to look something like this, right? And we have to check the behavior from minus 2 to 1, so this part. So minus 2 to 1, this opens up as, this box will open up as, this value anyway ranges from minus 1 to 1 itself, so this value will become 0, right? So the integral is just remained as 1, so minus 2 to minus 1, integral is 1, and then minus 1 to 1, right? Minus 1 to 1, the function is positive, highest value is 1, and we can just integrate it because this will become what, 2, then correct, this will become not 2, this will become 1, so we have box of x plus 1, and again we'll have to split this into multiple intervals, so this will just become minus 1 plus 2 plus integral of minus 1 to 0, which will be 0 dx, plus integral of 0 to 1, which is 1 dx. So final answer is 2, because this will become 1, this is 0, and 1 and minus 1 will cancel. So that's what is the answer. Another lengthy type question that can be asked is pi to 2 pi. box of 2 sin x. Now this is very weird because you'll have to draw the functions properly. Now graph gets elevated actually. Um, at sin x is equal to half, which is pi by 6, this function will become 1, and then like this only. When the function is at pi by 2, it's discontinuous. Same way for exact pi by 6, it's discontinuous. But the function behavior is almost identical to this. We can say that till this point it behaves like this, and then after that we can say that it'll behave around this way, and then again like this. So make careful when you get negative, because negative only the differences happen. So yeah, that's it for the session. I mean, we covered broad range of questions of calculus. So yeah,